In this topic, that is Nyquist Stability Criteria, we are going to understand how by using the Nyquist plot we can find the stability of the system. So previously we had done two questions. I am going to rewrite the statement for the first one. The first one was GS dot HS is equal to 10 divided by S plus 2. If I redraw its Nyquist plot, it was something like this. The direction was clockwise like this. Now by using this Nyquist plot, we can find the stability of this system by using this formula. N is equal to P minus of Z, where N is the number of encirclements of point -1 plus J0 by Nyquist plot. If the value of n is positive, that means the encirclements are in anti-clockwise direction. But if the value of n is negative, then that means the encirclements are in clockwise direction. Okay, the P over here is the number of open loop poles of system that are in the right half of S plane, while Z is the number of closed loop poles of the system in the right half of S plane. Okay, here if we see, the Nyquist plot is touching the origin and isn't touching any of the other point on the negative real axis. So if let's assume the point -1 plus J0 is over here, we can see this Nyquist plot is not encircling this point, so the value of n over here would be 0. To find the number of poles, that is P open loop poles in the right half of S plane, we will be equating this denominator equal to 0. From here we will know the location of the open loop poles. The first one is on origin and the other one is on -2. So that means there is no open loop pole in the right half. That means the value of P is also equal to 0. Now by using the formula n is equal to P minus of Z, we can find the value of Z, which is the number of closed loop poles of the system in the right half of S plane. So value of n is equal to 0, P is also equal to 0, and this way we calculate the value of Z, which is also equal to 0. So there is no closed loop pole in the right half of S plane, which means the system is stable. So this way we find the stability of the system by using the Nyquist stability criteria.